Imagine if we could travel backwards in time, across billions of years, going back to an era before the Earth even existed. The formation of our solar system. What would we find in that chaotic mass of rock and dust, and what could we learn about the nature of our own existence? Now, we may not actually be able to rewind the cosmic clock, but the solar system has conveniently left us with thousands of time capsules from the age of formation, the asteroids. There is no shortage of ancient rock floating around out there. All we have to do is capture one and bring it home, which sounds impossible, but it's not. And this is how NASA plans on doing it. This is the space race. Alright, here's the plan. First things first, we need to choose our near-Earth asteroid. There is no shortage of them. According to an article I found from 2016, there had already been 15,000 near-Earth objects identified, and the number is constantly going up. It's fine though, don't be scared. Our next best probability of impact isn't coming until 2095, and even then, it's a pretty low-risk rock at just about 7 meters across, with a 1 in 15 chance of hitting the Earth. Anyway, our ideal asteroid candidate needs to be relatively small for two reasons. One, we need to literally capture it and move the thing with a standard satellite-sized spacecraft. And two, we are going to bring this back to cislunar space, which is the area in between the Earth and the Moon. So even in a worst-case scenario, we don't want to introduce any new danger to the planet. We're probably looking for a chunk of rock around the size of a minivan. Next, we have to deploy our retrieval craft. Nothing too fancy here. The plan shows a long hexagon-shaped box, relatively the same size as a large communications satellite. It would be equipped with 2 large solar wings that would power electric ion thrusters for efficient travel into deep space and back. After a journey through the void, our spacecraft finally meets up with the asteroid. Now, how do you capture it? One thing that we've learned about asteroids over time is that they are not all necessarily solid. Some are literally just boulders in space, but others are more like floating rubble piles, a kind of loose mass all stuck together. This kind of asteroid, with a looser, more diverse composition, would be the most interesting to study, but that also means that we can't just grapple or lasso the thing like a space cowboy because it might fly apart. So, instead, we throw a bag over its head and kidnap the asteroid like a Liam Neeson movie. The retrieval craft is going to unfurl a giant containment bag that will envelop the space rock. Once inside, the bag is going to contract and tighten around the asteroid, pulling it in tight to the craft. There's also an alternative version of this plan that involves sending the craft to a much larger asteroid. So instead of capturing the whole thing, a robotic arm would essentially snatch a giant boulder from the surface of the asteroid and contain it using the same Liam Neeson bag method. Okay, so we caught an asteroid. Now, bring it back home so we can get a close look at this thing. The retrieval craft is going to return to cislunar space under power from the ion thrusters, and it's going to settle into a distant retrograde orbit around the Moon. Basically, just a very high circle. Once inserted, it can basically stay there indefinitely. Next up, we actually pay the first visit to our new friend. This involves sending a crewed vehicle up to rendezvous with the retrieval craft. From there, 2 astronauts will conduct a spacewalk from their craft over to the asteroid, at which point they unwrap the bag and become the first people to examine an intact space rock up close and personal. Once contact is made, they can take a bunch of high-resolution close-up photos, and most importantly, collect a wide range of samples, everything from the surface dust to large chunks from the interior. This NASA rendering shows one person going to town with a pickaxe like Yukon Cornelius in space. NASA has actually even had astronauts training for this exact scenario in underwater simulation drills in the Neutral Buoyancy Laboratory at Johnson Space Center. Then, the crew simply transit back to their spacecraft and set course for Earth. The biggest benefit here is that the asteroid will stay in place around the Moon, so we can always go back and take more samples and conduct more experiments with future missions. Obviously, we have already sampled asteroids in the past. The Japanese Space Agency has been highly successful in this area with their Hayabusa and Hayabusa 2 missions, but these samples are extremely limited in scope, but they can basically just come down to grab a handful of surface material in a touch-and-go kind of maneuver. The Japanese sample returns are a massive achievement, but their small scale makes it difficult to get the whole story. Imagine if you went out to a beach and scooped up a little bucket full of sand. That one sample might contain different types of rocks, little seashells, fish bones, human garbage, seaweed, water, ash, cat poop, or it could have none of those things and just be some sand. You would never get the full story of that beach just from one single sample. So, in order to really learn everything that an asteroid has to teach us, we need a holistic sampling approach. Now, you may be wondering what's so special about an asteroid. If we want a space rock, we've got a whole moon just right above us. Well, planets and moons are like living beings. They are constantly evolving and reinventing themselves. Even our moon, which appears totally dead, was once a raging volcanic world with an active molten interior and a dense atmosphere. This was a period between 3 and 4 billion years ago. So even the moon has had any traces of the early solar system wiped away and changed over the course of its evolution. If we really want to travel back deep into time to see things the way they were before the violence of planetary formation, we need these undisturbed time capsules. The solar system formed around 4.5 billion years ago, beginning life simply as a dense cloud of interstellar dust and gas. At some point, there was an instigating action that put our solar system into motion, likely a shockwave from a nearby supernova that collapsed the cloud. The compression of all that material formed into a solar nebula, a spinning, swirling disk with a gravitational well at the center. As more material is pulled in and pressure builds up to an extreme, hydrogen atoms begin to fuse into helium and trigger the nuclear reaction that becomes our sun. Over 99% of all mass in the nebula will be pulled into the star, while the remaining 1% continues to spin around. Over time, the remaining nebula starts to clump up and form larger objects, which then smash into each other and form even larger objects, and so on and so forth until we have planets and moons. At some point, the chaos of the nebula forms into an ordered star system with nearly all of the available material concentrated in these large structures, and everything left over is now just free-floating around in the void. These leftover materials from the solar nebula become what we call asteroids. They are still waiting for the opportunity to collide and combine a larger body, but the density of the solar system is now so low that their odds of hitting anything else are pretty slim. We talk about the asteroid belt as a dense concentration of objects, but this is speaking in relative terms. You might picture the scene from Empire Strikes Back, but in reality, the gaps between asteroids are hundreds of thousands of miles across. It's only dense compared to other areas of space that are completely barren. Anyway, the point being that depending on the asteroid, it could still be carrying materials that have been unchanged since the era of planet formation in this solar system. That is a window across 4 billion years of time, which is a fascinating thing to be able to see and study. So everything that we've just discussed about finding an asteroid, capturing it, and bringing it home for study comes from a plan that NASA released 10 years ago. Obviously, this still hasn't happened yet, and unfortunately, it won't be happening anytime soon. As of 2017, the Asteroid Redirect Initiative was taken off the official roadmap. This was the same year that the Artemis program was formally announced, so obviously NASA had to restructure some priorities in order to get people back to the surface of the moon within the ambitious new timeline. And that's perfectly fine. I'd take the Artemis program over the Asteroid Initiative any day. But that doesn't mean that we can't come back to this plan at some point in the near future once we've got the moon situation figured out. And we should do that. For all of the reasons just given, asteroids are cool, but also now in the 10 years since the mission concept was designed, we've had a lot of great advances in our spaceflight capability. We have a lot more options. For one, if this whole SpaceX Starship program pans out like Elon is promising, then we could just send one of these gigantic steel ships to scoop up a small asteroid and bring it back. The Starship could even land on the moon with the asteroid and deliver it to the Artemis moon base, where teams of scientists from all over the Earth could go up and study it as much as they want. A Starship could even bring a whole asteroid back to Earth. Figuring out how to safely contain it and transport the thing would be tricky. It spent billions of years soaking up galactic cosmic radiation, and who knows what else. But we could find out, or release a space plague on the Earth. As long as we're careful though, we should be fine. And even if NASA doesn't want to go forward with this plan, any nation or private research team could buy a Starship flight. Elon has been promising that this could eventually cost as little as a few $1 million, and they could do an independent asteroid retrieval totally separate from NASA. This is the kind of stuff that becomes possible when heavy lift launch hardware is made accessible and affordable. Just something cool to think about for the future. Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it. That really helps us out for real. And subscribe to the Space Race for more videos just like this. We do one long form essay and one news update every week. And if you'd like more, we've got 2 more on the screen for you right now.